Okay, so again we're talking about fractions, we're working with number. This is a lot of revision stuff, so all these things you should have seen before. So we'll carry on with this, let this work. Yes. Good. So now fractions are rational numbers. Okay? Rational numbers is just a definition. We also have irrational numbers. So a rational number you can write as a fraction. Okay? So actually a fraction is a very important concept. Any number that's what we call rational, you can write in a fraction form, a over b. Now, so any decimal that terminates, as it has an ending, has a limited number of decimal places, is rational. Any fraction is rational. Any whole number is rational. Repeating decimals are also rational. Because repeating decimals you can write as a fraction. An irrational number is a number that has an infinite number of decimal places. The decimals never end, and there's no pattern to it. So, for example, pi is an irrational number. 3.14 goes on forever. At no point in pi is there a pattern that follows itself after the other. The square root of 2 is also a rational number. You can put in square root 2 into the calculator, but equals, you will get a very long decimal that actually goes on forever. So that's an irrational number. You can't write that as a fraction. So a proper fraction has a numerator which is less than the denominator. For example, 3/4 is a proper fraction. An improper fraction, even though it's the opposite of a proper fraction, has a denominator which is smaller than the numerator, or the numerator greater than the denominator. So for example, 8 over 7 is an example of 15 over 12. All these are examples of improper fractions. And the final one, mixed numeral, are numeral and a proper fraction together. So for example, 4 and 5 over 6, or 2.5. Okay, whatever. You can have all sorts of them. Just means the whole number, an integer, can be positive or negative, with a proper fraction after. Okay? That's just the way it's like. So those are 3 things that we need to remember, and fractions are rational numbers, a over b. I'll just let you write that down. You've written that already, go to the next heading. Okay. Now to change a mixed numeral into an improper fraction, very straightforward. You multiply the numeral, the whole number, with the denominator, multiply them together, and that product, that answer you get from the two things multiplied together, you add to the numerator. So if you do that, then it becomes an improper fraction. Alright, so you multiply the denominator with the numeral, and then you add it to the numerator. Alright? So in this case, this example, we've got 2 3/4. 2 3/4, we want to write it as an improper fraction. So we take the numerator, we take the denominator, which is 4, the numeral, which is 2. So what we do is 2 times 4, I'll just write it up here, equals 8. So this becomes 8 plus 3 over 4, which equals 11 over 4. So 2 3/4 as an improper fraction is 11 over 4. Right? So it goes in, and if you think about it, 4 goes into 11 twice, you get to 8, and then there's 3 left over. Hence you have 2 3/4. Okay? Another example that we'll do, 4 2/5. Well, 4 times 5 is 20, so we have 20 plus 2 over 5, and so it becomes 22 over 5. I think we've got 22 over 5. So just multiplying. Now, you can also use a calculator for all of these. Spending time, it's very straightforward. As you get more practice at it, as you see more of them, you just sort of recognize what it is. But if you type in 2 3/4 and then press the fraction button, you'll be able to just convert between improper fraction and mixed numerals. Okay? So my recommendation is is that to go from an improper fraction to a mixed numeral, type it into your calculator and it will convert it for you. So if everyone has a calculator, get it out and just type in any sort of improper fraction, something where the numerator is bigger than the denominator, and by default it will make it a mixed numeral. So it should be like 11 over 4, or write it as 2 and 3/4. Okay, it does that for you. Right? So these are sort of things, just got to use the calculator. The calculator is a tool for you to use, but you need to know how to use it. Okay, and if you do know how to use it well, it can be a great help with these things. Alright, just a couple of things. So use the calculator to help you with these things. A couple of seconds just to finish writing this down. I just want to make a couple of notes about things. When we talk about simplifying a fraction, if you want to simplify a fraction, it just means you're cancelling out, or you're dividing the numerator and the denominator by a common factor. Okay, so something that's both the numerator and denominator have a common factor, you can cancel them out. And again, the calculator can help you with this. Right, if you type in 10 over 12 in the calculator, it will automatically bring it up as 5 over 6. Okay? Because it knows that both numerator and denominator have a factor of 2, so it cancels that. Divides both top and bottom. Okay, so that's what we're talking about. We're talking about simplifying fractions, talking about writing it in its simplest form. And there's no longer a common factor in the numerator and the denominator. Apologies today, just sort of skipping through a few things, so there may be a little bit more writing, but I promise that all lessons will not be like this. In fact, most lessons should not be like this. Just early in the year, trying to get through things, to go over them from previous years. Okay? Any questions? Just nod your head if this is seeming at all familiar. That you have recognized at least that you have seen this. Very good. Right. Can I move down? How are we going? Good. Now, an important concept with fractions is equivalent fractions. Equivalent fraction means that the value of the fraction is still the same, but the way you write it is different. And to find equivalent fractions, all you have to do is multiply the numerator and the denominator by the same quantity, the same amount. Okay, so all equivalent fraction means is, well, a half, we write it as 1 over 2. But another way that we could write half, well, 3 is half of 6. So we just write, well, 3 over 6 is also equivalent to a half. It's written differently, but the value is exactly the same. So 1 is half of 2, 3 is half of 6. Or you can write it as 45 over 90. Right? 45 is half of 90. So these are equivalent. They're the same value, we just write them differently. And the reason we have this is because to compare fractions, to do some operations with fractions, we need to know, we need to be able to change the denominator and change the way we write it, to be able to add it in. Add them together or subtract them or whatever we want to do. So this is an important concept. Equivalent fractions. So there's lots of ways you can write any fraction. You can write it however you want. Just recognizing that the value of these is the same. Okay? So you could also have it 3/4 is the same as 9 over 12, which is the same as 15 over 20. Okay, so all these are equivalent. 3/4, 9 over 12, 15 over 20 are the same fraction. Same fraction, it's just written differently. Now I just want to have a look at this example. So just finish writing this equivalent fraction bit and put your pens down for a moment and let's listen to what I do here. It's kind of we have this square blank, so we want to find what's in this box. in the numerator above the 5. So let's put your pens down for a moment. And these are the sort of questions that get a lot of exposure, I would say, Mr. Mills. Yeah, you see them in questions and exercises, and they pop up in assessments and tests often. Because it's a very good way of testing your understanding about quite a few things. About what a whole number is, how you can convert an integer, a whole number, into a fraction. The idea of equivalence, as in how do we write fractions in different forms, all these type of things. It's a good way to see how your understanding is going with that. Right, so let's have a look. So what we're saying is we need to put something in this box that will make, so something over 5 will be an improper fraction with a value that's between 6 and 7. So the way we approach this is, let's write 6 and 7 as fractions with denominator 5. So firstly, and I'll make a note of this here, an integer is a fraction with denominator 1. Okay? So 6 is just 6 over 1. So let me ask you a question. 6 over 1 equals what over 5? How do we get from 1 to 5? Slow down. Times it by 5. Okay. So we times it by 5 here. So if we times the bottom by 5, what do we have to do with the top? Okay, we also have to times it by 5. So we end up with 30 over 5. Now, we can also do this with the 7. So 7 is equal to 7 over 1. How do we make this into a fraction with denominator 5? Right? How do you get from 1 to 5? You need 1 by 5. Yeah? So what do we have to do with the numerator? Okay, so what are we going to end up with? 7 5s are 35. So what we're saying is 6 is equal to 30 over 5, 7 is equal to 35 over 5. What's a fraction that's between these two values? What's a fraction between 30 over 5 and 35 over 5? Adriana? Give me one. You have a few choices. Yeah, that's right. 33 over 5 is between them. So the answer could be, the box could have 33 over 5, or it could have 31 over 5, it could have 34 over 5, it could not have 34. So those are the 4 possible options. So all these fractions have a value between 6 and 7. All right, that's what it's trying to find. It's saying, well, we know what is equivalent, how to change 6 into an equivalent fraction, and we also recognize what the values are between these two and how it works. It comes together. Are there any questions about it? We've seen these questions before. I remember them from doing them last year and things like that. So hopefully coming back to it gives it a sort of you can see it again and go over it and have a fresh look at what's happening there. So that's a kind of important thing to think about. So knowing about equivalence, knowing about comparing fractions, and also taking note of this. Okay, an integer is simply the number with the denominator 1. Okay, so divide it by 1, denominator 1. Just write down an example. Oh. So what I'd like you to do actually is I'm going to go down to exercise. So before we go on with the other parts of the lesson, sorry, it seems like a lot, but it's just mostly space examples. I'd like you to do up to, let's do up to this question 7 here. Okay? I would like you to do the exercise up to here. I'll stop talking. So I want you to do the exercise from there for about, let's say 15 minutes, about 10 past. Then we're going to come back and I will continue to just go through the operations with fractions. Okay? It doesn't have WhatsApp. Really? Okay, so we're just going to quickly talk about addition, subtraction, multiplication, and division. Let's go through a few examples. Alright, so addition and subtraction, when adding and subtracting fractions, the denominators must be the same. Okay, this is, you have to do it with the same thing. You have to convert the denominators, so make the fractions equivalent to something else with the same denominator, and then you can do the operation. Okay, and to find a different denominator, you just multiply it by an appropriate quantity or appropriate value. Now, what's the easiest way to add and subtract fractions? No, I think even easier than that. What do you think it is, Mrs. Mills? Use your calculator. Do not waste your time. If you're given stuff with fractions, if I have two fractions, 3 over 17 plus 5 over 15 or something, I am not going to spend the 3 minutes it will take me to convert, to multiply the two together, find the common denominator, make sure they're converted properly, add the numerators, and then simplify it. I'm just not going to do that. Why is that? Because I don't have to. The calculator does it for me. But it is important to know what's happening. But if you don't quite understand it or you're not confident with, say, difficult examples or more difficult cases, the calculator is there to help you. Right? With a calculator, you don't have to have the same denominator. It does all that working out for you. However, it's good to know how to do it. And the other good thing is the calculator will always simplify fractions for you. So if ever a question asks, write the fraction in simplest form, and if you're unsure what the simplest form is, make sure you just type it in as you see it, and the calculator will give you the answer in its simplest form. Okay, so it's a great tool to have. Just like I said before, you need to know how to use it properly and to do that. So we'll just show you these couple of examples of what we're doing. So quarter plus 2/5. Common denominator will be 20. Common denominator will be 4 times 5. You multiply the denominators together and you get 20. So 1 over 4, 1/4 equals what over 20? 1 over 4 equals what over 20? Yeah, 5 over 20. 5 over 20. And Annabelle, 2 over 5, what is it over 20? Okay, so then how do you get from 5 to 20? Times by 4, good. So if we times that by 4, what do you have to do to the 2? Good. So what are we going to end up with? 8. Excellent. Thank you. Alright, so 5 plus 5 over 20 plus 8 over 20 equals what, Jamie? 5 over 20 plus 8 over 20 is 13 over 20. Are there any common factors between 13 and 20? No. 13 is a prime number. Sorry. Oh, yes. So 13 over 20 is the answer to this one. Converted into equivalent fractions, and you've found the simplest fraction. Right? But again, can't use the calculator to say all that work, but it is good. Look at this next example. 7 over 8 minus 5 over 6. 7, 8 over 5 over 6. The common denominator for this one we can have it as, let's do 8 over 6, 8 times 6. The easiest way to do it equals 48. So we think about it. Just cutting out a couple of steps here. 7 over 8 is 1 over 48. Brooke? How do you get from 8 to 48? By 6. So then what do we have to do with 7? Good, and what's that going to be? Good, 42. And then, good, what about, how do we get from 6 to 48? Times it by 8. Alright, so what do we have to do with the 5 here? Times the denominator by 8, so we have to times the by 8. So what 5 eighths are? 40. Alright, so 42 over 48 minus 40 over 48, Chris, is 42 over 48 minus 40 over 48 equals what? 8. I'm glad the denominator stays the same. What's 42 minus 40? 2. So we just have 2 over 48. And if we simplify that, we divide top and bottom by 2, we get 1 over 24. And that's in simplest form. So here we've converted to a common denominator equivalent fractions here, and we found that it's 1 over 24. Okay? So that's what I won't do the third example because I want to talk all day long. We move on to multiplication. The good thing is multiplication is even easier, it's very straightforward. Okay, so we just go ahead and do that. Okay. So multiplying fractions. You multiply the numerators together, then you multiply the denominators together, and then you simplify. Okay, it's very straightforward. Top, multiply them together, the bottoms, you multiply them together, and then simplify. And again, I made this note, an integer is a fraction with denominator 1. So when multiplying an integer with a fraction, write it with a denominator 1, or whatever it is, 5 over 1, or minus 4 over 1. So you can multiply the numerators, multiply the denominators. Okay? If there are mixed numerals to multiply, and we just did this, so you should be fine, change them into improper fractions first. Okay, so if you're given 1 or 2 mixed numerals to multiply with, change them into an improper fraction, and then multiply them. Alright? So there's a couple of examples. Let me just do this. Let's have a look at this first example. 3/5 times 4 over 7. 4 7. All we do is multiply the numerators. 3 times 4 over, multiply the denominator. 5 times 7. What's 3 times 4, Emily? 12. 12 over 5, 7 is 35. So that's it. Multiply the top, multiply the bottom. And that's all that is. The next one we have 9 times 3 over 5. Okay, so we need to make sure we don't make the mistake of multiplying top and bottom by 9. We can rewrite this as 9 over 1 multiplied by 3 over 5. What's 9 times 3? 27, good. Multiply the numerators and then multiply the denominators. 1 times 5 is just 5. Good. So 27 over 5 is the answer to this one. Okay, just multiply the numerators, multiply the denominators. The final one here, we first need to change them into mixed numerals, into improper fractions. So they are mixed numerals, we need to change them into improper fractions. So we take the steps that we've been working on already. 6 times 5 is 30, add it to 4, so it's 34 over 5, times 3 times 3 is 9, plus 2 is 11 over 3. Okay, what's 11 times 34? Don't expect you to know this. 11 times 34 is, Adriana? 374. And then 3 times 5 is 15. Now type this into your calculator, everyone, and see if it simplifies it. Is there a common factor between 374 and 15? Does it simplify? You type it in, press equal. 275, that's alright. 275 over 374 over 15. 24 and no, it doesn't simplify. So you can write it as a mixed numeral, but it doesn't have any common factors. So the answer is 374 over 15. We're on to our final part, and then we're finishing, well I'm finishing talking, and we'll continue the exercise. So we're talking about reciprocals and dividing fractions. So I think you saw it in the exercise already. A reciprocal is just when you flip the numerator and the denominator around. Okay? The product of a number and its reciprocal is 1. That's the definition. But all you're doing to find the reciprocal of a number is just swapping the numerator and denominator. So the reciprocal of 2, which is 2 over 1, is 1 over 2. It's a half. Reciprocal of 3/4, 3 over 4, is 4 over 3. Okay, so you're just flipping it upside down. So it's very straightforward. That's the definition of reciprocal. And we need to know this because you have to find the reciprocal when you're dividing fractions. And so when you're dividing fractions, very similar to multiplication, just has one extra step. Change the second fraction to its reciprocal, so flip it upside down if you like to think of it like that. And you try and change the division sign to multiplication. Okay, so you don't divide it, you multiply it, and you change it to its reciprocal, and then it becomes just a multiplication. And we know how to multiply fractions already. So that's very straightforward. Okay, so I'll just let you write that. We'll do 2 examples, and we'll continue on with the exercise. So last 10 minutes. Alright, so this one, the first one, just looking at this example here, the first one stays the same. We don't do anything to it, 6 9, we'll just keep. What's the reciprocal of 8 over 3? 3 over 8. Alright, so it's 3 over 8 we write, and we change this division sign into a multiplication. So then all it is 6 times 3 over 9 times 8, which equals 18 over 72. Please type that in to see if it simplifies at all. Alex, can you type that in to see if it simplifies at all? 18 over 72. Tell me what the result is. 1 over 4. Thank you. So it simplifies nicely, and we end up with 1/4. Okay? So that's it. You switch the second one around, find its reciprocal, and then you multiply them instead of divide. Again, when you have mixed numerals, you have to change it to an improper fraction. So 4 2/3 is 14 over 3. Let's change it to multiplication, and the reciprocal of 5 over 6 is 6 over 4. So we change the reciprocal, and that equals to 84 over 15. 84 over 15 milli. Can you simplify that at all? Can you find out for me? 28 over 5. Excellent. 28 over 5, and that's how we do it. Right, all this again is revision. We've gone over this before. A refresher. So now I'd like you to go see these questions right at the end. So after question 9 to 15, ACE only, and then 19, 21, 23. So leave question 1 to 7 if you haven't finished it. Move on to the second part. Alright, so we have 10 minutes, and we're going to go and have recess.